Hello everyone. So we were doing definite integrals. Okay, so let's prove some of the properties of definite integrals. We have seen the properties. Okay, we'll prove 2 or 3 properties of definite integrals. Okay, so I'm going to prove the property integral a to b fx dx is equal to a to b f of a plus b minus x dx. This property I am going to prove. Okay, so start with LHS, left hand side. Okay, so put t equal to a plus b minus x. Okay, so dt by dx, this derivative of this will be minus dx, right? So as your t and x changes, your limits also change. Okay, when x is equal to a, when you put x equal to a here, you will get t equal to b. Okay, and when x is equal to b here, you will get t equal to a. Okay, so our limit starts from b to a when we change the variable, that is x, to t. Okay, so LHS becomes integral b to a f of, in place of x we are writing this term, that is a plus b minus t. Okay, and dx becomes minus dt. Okay, you can take this minus sign outside. Okay, so this will be b to a minus, so here you can apply the property which says a to b f of x, you can write it as b to a minus b to a f of x dx. Okay, so you have to just change the limits and that minus sign will come, that minus and this minus will become plus. So this will be a to b f of a plus b minus t dt. Okay, and using the second property which says a to b f of x dx is equal to a to b f of t dt. So when you are changing the this variable, you can change here also variable, so t becomes x. Okay, so you can write a to b f of a plus b minus x dx. Okay, so this is equal to your RHS. So this property is proved. Let's prove this property. Okay, so start with your LHS. So this is from 0 to 2a. So you can split the limit. Okay, 0 to a I can write, 0 to a I can go, and a to 2a I can go. Okay, so I am splitting the limit. So 0 to a fx dx plus a to 2a fx dx. Okay, now you can label this integral as I1 and this integral as I2. Okay, so this we got. Okay, this is there. We have to solve this I2. So consider I2. So considering I2, we have to put t equal to 2a minus x. Okay, so your dt will be equal to minus dx. Now you have to change the limits also. So when x is equal to a, in this you will get t equal to a. Okay, when x is equal to 2a, in this you will get t equal to 0. So you have to change the limits here. So it will be LHS equal to limits are from a to 0. Okay, f of, in place of x you are writing 2a minus t, and your dx becomes minus dx. So this minus you can take outside. Okay, now you can apply the property in which you can change the sign, that is you have to change the limits and sign goes. Okay, so this will be 0 to a, and the negative comes which gets multiplied with this negative, then it becomes positive. So f of 2a minus t dt. Okay, so this you can write as 0 to a, that you can change t to x using again the property. Okay, so this is our this integral. So we got both the integrals. Okay, let's prove this integral property. Okay, so here minus e to a fx dx is given. If the function is even, you have to write 2 times 0 to a fx dx. Okay, and if the function is odd, you have to write the property 0. So when the function is even, when f of minus x, you will get f of x. Okay, and when the f of minus x is equal to minus f of x, that time the function is odd. Okay, so now let's prove this. So take LHS so that you can split. Okay, split the limit. So minus a to 0 f of x dx plus 0 to a f of x dx. Okay, now you can write this as I1 plus I2. So let's solve I1. Okay, because I2 is already of the form 0 to a. Okay, so solving I1, put t equal to minus x. Okay, so dt will be minus dx. Now change the limits. Since it is minus a, when x is equal to minus a, you will get t equal to a, right? And when x is equal to 0, you will get t equal to 0. Now change the limits and see what you get for I1. This is a to 0, right? F of, in place of x I am writing minus t, and this is minus dt. So you can take this minus sign outside, then applying the property in which the limits change and minus sign comes here, you will get 0 to a f of t dt. Now changing the variables t and dt, x I am putting using again the property. Okay, so I will get this. Here minus x, because it is minus t, right? So now this comes in I1. In place of I1 you can write this. Okay, so I will write it here only. Change that. In place of I1 I am writing. So 0 to a f of minus x dx. Okay, now when function is even, that time f of x becomes, f of minus x becomes f of x. Okay, that time these two gets add up and you will get this 2 times 0 to a f of x dx. When the function is odd, that time f of minus x will be equal to minus f of x. So this will be minus f of x. So minus f of x and plus f of x, you will get 0. Okay, so this is proved. Now let's see a subtopic. Okay, so definite integral as a limit of the sum. Okay, you can express definite integral as a limit of the sum. So in this, need to know a to b f of x dx is equal to, you can express it into limit as h tending to 0 summation r from 1 to n f of a plus r h into h. Okay, where your h is b minus a upon n. So b and a are from the limit. Okay, so this formula you have to use and solve definite integral. Okay, so let's solve one problem. Okay. Integral 1 to 3 5x plus 6 dx. Okay, so first you identify what is a is 1, what is b, which is 3, and write h. You will get b minus a, which is 3 minus 1 by n. So this you get 2 by n. Okay, so your h is 2 by n. Now find out f of a plus rh. Okay, so your f of x is 5x plus 6. Okay, so write f of x is 5x plus 6. So f of a plus rh, that is in place of x you have to put this. So 5 a plus rh plus 6. What is the value of a? A is our 1. Okay, so 1 plus rh. So this you will get 5. This you can put in this formula. Okay, you have to substitute in that formula. So this will be 5 plus 5 rh plus 6. So 5 plus 6, this becomes 11. So your term is, final term is 5 rh plus 11. Okay, this you have to substitute here. So I'll rub this. Okay, I'll write here the value of h. Okay, 2 by n, that we need to substitute. So let's write in the limit form. Okay, so your LHS becomes equal to limit as h tending to 0 summation r from 1 to n, and we got what was that, 5 rh plus 11, right? This is your f, value of f into h. Okay, now let's solve this. So limit as h tending to 0, so you can take out 5 from this, so you will get 5, and also h you can take out because summation is from r. Okay, so summation r from 1 to n plus 11 you can take out, so summation r from 1 to n 1 into h. Okay, so this summation r from 1 to n for r will be what? This is series. Okay, series of n. Series of n is given by n into n plus 1 by 2. Okay, so you can write here directly n, limit as h tending to 0 5h into n plus 1 by 2 plus 11 into, now summation 1, so we are adding 1 n times, so this will be n. Okay, into h. Okay, now you have to substitute value of h. Okay, or you can substitute value of n. So from this your value of n is 2 by h. Since we are taking limit from h is going to 0, so put n. Okay, in place of n you have to substitute h. So n will be equal to 2 by h. I will write here. This 2 I will write here, so that I can replace this n by 2 by h and this n by 2 by h. Okay, this is inside. Again this will be 2 by h. Okay, this h and this h gets cancelled, 2 gets cancelled, so here you will get only 5. Okay, this remains. This h is there, this you can take inside, so this will be into h into h. Okay, so this also goes, so here you will get only 22. Okay, this here to expand, so this will be 2 plus h upon h. 2 plus h upon h. So you can cancel this. So you will get here 5 into 2, that is 10 plus 5h. Okay. So now you can put h tending to 0. So this term will be 0. So you will get only 10 plus 22, which is 32. So the answer is 32. Okay.